everybody, Rachel here. Today I'm going to talk about double blinding because you've probably heard of it before, but you might not know exactly what it is. As you've probably heard before, the gold standard for clinical trials is the double-blind, randomized, controlled trial. When you're doing a study, whether it's to try to figure out the cause of a disease or to see if an intervention that you've created helps or cures a disease, you want to try to make sure that you've introduced as few potential errors into your study as you possibly can. There are many different types of potential errors. For instance, the random effect error. Just by chance, the group that you're studying might show the effect that you're looking for, but it isn't a real effect. The way to try to avoid the random effect error is by having a large sample size. Confounding can also introduce potential errors into your study. A confounding factor is one that is associated with both the intervention you've created and the effect you're looking for. So you might think that it's the intervention that you've created that is causing the effect, but what it really is the confounder is there skewing your results. There are also many different types of bias that can creep into your study that you want to try to eliminate. You could have some sort of selection bias, where you have one group of people that are receiving the intervention and another group that are not, but the two groups differ systematically in some way. That's bad and will mean that you can't generalize your results to anyone else. That's what randomization is for. And there are also lots of types of observer or information bias, where there are differences in the way the groups are being studied or the data are being analyzed. Double blinding is used to try to eliminate some aspects of bias. Okay, definition time. A double-blinded study is one in which neither the participants nor the investigators know which group each participant is in. So neither the participants nor the investigators know who's getting the treatment or a control. Ideally, having neither participant nor investigator know is important for two reasons. The first is the placebo effect. You've probably heard of this before too. Some people experience a benefit even if they've received an inactive substance or a sham treatment, as long as they believe that they've received the real thing. To try to control for the placebo effect, public health and clinical trials don't just give an intervention to the treatment group. They also give something that seems like the intervention to a control group. But if your participants know which group they're in, there's no point in doing that. Some people do benefit from placebos, even if they know they're placebos, but not everyone. And so if your participants know that they're in the treatment group, you can see how that would seriously skew your results. The other reason why you don't want participants or investigators to know who's in the treatment group and who's in the control group comes from the other side, and it's called demand characteristic. This concept originally came from psychology experiments, but it's been found to affect public health and medical interventions too. It's really just a fancy way of saying that if the investigators know who's in the treatment group and who's in the control group, they can make the participants aware of what outcome they're expecting from them. For instance, say you're studying pain medication and you know who's in the control group. Well, you might be a little more eager when you're asking the participants that are in that group about any headaches they might have had. This isn't necessarily intentional, it's just human nature, but it's very easy to do without meaning to. This is also known as the observer expectancy effect. An observer's expectancy of the results of an experiment can have an effect on that experiment. And another aspect of it is known as confirmation bias, and that's the tendency to search for, interpret, favor, and recall information in such a way that it confirms or strengthens your prior personal beliefs or hypothesis. You can see how that can skew the results of public health and clinical trials. So we try to blind experiments as much as we can. The first blinded experiment was done in 1784 by the French Academy of Sciences, and it was done to try to investigate the claims of mesmerism. Mesmerism was invented by a man named Franz Mesmer, who believed that an invisible natural force was possessed by all living things, and that force had physical effects, including healing. He also believed that this vital fluid could be manipulated by people that he had trained to feel it. In the blinded experiment, the researchers literally blindfolded self-proclaimed mesmers and asked them to identify objects that had been previously filled with the vital fluid by the mesmers. Of course, they couldn't do it. This wasn't double blinding because the researchers knew which objects were which. Instead, it's what's known as single blinding, where, for instance, the investigators know which group a participant is in, but the participants don't know. Single blinding can help a lot with the placebo effect, and it is still used today in cases where it would be unethical or impossible to double blind. In the latter half of the 19th century, Claude Bernard, a famous French physiologist, began advocating for the blinding of researchers as well as participants, recommending that the observer of an experiment should have no knowledge of the hypothesis being tested. But it wasn't until 1907 that the first double-blinded experiment was run, when William Halls Rivers, great name, did an experiment to investigate the effects of caffeine. Blinding the researcher was necessary, in Rivers' words, to try to eliminate all possible effects of suggestion, sensory stimulation, and interest. But it wasn't until the middle of the 20th century that the need for blinded researchers became widely recognized. Nowadays, well-run randomized trials are double-blinded whenever possible and ethical. Unfortunately, our problems don't stop there. Sometimes, participants figure out whether they've received the treatment or a control. This can happen in a number of ways. Maybe a participant is experiencing a number of side effects and becomes convinced that they've received an actual medicine. Or maybe several participants get together to compare symptoms. An investigator can also deduce who's in the treatment group and who's in the control group, especially if they know what side effects are likely to occur. When this happens, either for a participant or for an investigator, it's called unblinding, and it's a new source of experimental error since it's reintroduced the bias that the blinding was supposed to eliminate. And unfortunately, it's pretty common. Meta-research, which is the use of scientific methodology to study science itself, has revealed fairly high levels of unblinding in pharmaceutical research, especially in studies on pain medication and antidepressants. And you can see why. Some research has shown that at least 3/4 of participants in antidepressant trials have guessed their treatment groups. And some researchers even believe that antidepressants aren't effective at all for the treatment of depression, that they're all just beneficiaries of consistent unblinding. One way to try to avoid this problem is to use something called an active placebo. An active placebo is one that produces noticeable side effects similar to those of the actual treatment. For instance, some researchers use lorazepam as the placebo for pain medication studies because it produces sleepiness and dizziness, which are both side effects of painkillers, but lorazepam is not itself a painkiller. Still, unblinding is a problem, and it's a problem that tends to introduce bias that favors the experimental group, since participants and investigators who know they're in that group expect better results. And this results in inflated effect sizes between the experimental group and the control group, and it also increases the risk of false positives. Even a small error in blinding can produce statistically significant effects in the absence of any real difference between the experimental group and the control group. So many statistically significant results of clinical trials might simply have been caused by an error in blinding, and that's bad. But what might be worse is that unblinding often goes unreported. The Consort Reporting Guidelines recommend that all studies assess and report unblinding, but it doesn't often happen. Consort is the consolidated standards of reporting trials, and they were developed to try to alleviate the problems that arise from inadequate reporting of studies in general. That's a whole nother video. Consort doesn't even like the term double-blind anymore because it could be ambiguous. It could refer to the participants and the investigators, as it usually does, or it could refer to participants and data analysts, say, or investigators and some sort of monitoring body. But the term double-blind is still in common use, and it probably will continue to be so. Usually, if someone refers to a study as double-blinded, they mean the participants and the investigators. Studies can even be triply blinded, which is usually the participants, the investigators, and data analysts. But even though it would be best to assess the blinding status of every study, it's a difficult thing to do. Unblinding often can't be measured directly because just the act of asking participants or investigators to guess masked information, and how else are you going to directly know the unblinding status, can lead to them trying to infer that information, leading to unblinding, the very thing that you were trying to measure and avoid. So indirect statistical methods are used, which are complicated, a further use of resources, and might lead to your results not being statistically significant. So you can see how many investigators don't want to do it. Sometimes unblinding must occur during the course of a study for the safety of a participant. And so each study should have a code break procedure, a set of rules determining when planned unblinding should occur. FDA guidelines recommend that every study should have a code break procedure in their standard operating protocol. Recommend, so it doesn't always happen. But even with these potential problems caused by unblinding, a double-blind procedure is the best way that we have to try to eliminate observer bias and the placebo effect in public health and clinical trials. So, when you're reading about a new study that is touting an amazing new discovery, look to see if it was double-blinded. That won't ensure that the study was a good one, but it's a start. I hope you enjoyed this video. If you did, and you think you'll be interested in more videos about public health, click like and subscribe. Thank you. I hope to see you soon.